Hello, welcome to another lecture. Today we're going to look at lecture 2, factorization and algebraic fractions. So factorization, we use this in algebra, of course, because we need to rewrite expressions. We need to manipulate expressions when we are isolating our variables, combining like terms, etc. So first, we're going to look at a common factor. So if you have an expression like this one, a times b plus a times b plus a times c, we can see that they have a common factor is a, so we can factor it out, right? And that's pretty much what it is when you factorize, pull out the common element they have. And then you're going to have your common factor in an expression inside a parenthesis. In this case, is going to be b plus c. All right. Um, Basically, we are undoing this one, this distributive law. Okay. Undoing it. Because if we do it, if we apply the distributive property, we are multiplying a times b plus a times c. So we're just going back to this, okay? Distributive property. Difference of two squares. Where's my scrolling bar? So difference of two squares simplifies to this, a minus b times a plus b. A very common example used in mathematics to illustrate this would be x squared minus 4. So this is a square, this is a square, so it's going to simplify to the product of the sum and the difference of the two um, terms, numbers, or variables which are being squared. So in this case, it's 2x plus 2. Okay. It could also be with an expression. We can have an expression like a plus b squared minus c squared, 6 squared. So same same approach. The product of the sum and the difference of these two terms. So it'll be a plus b plus c times a plus b minus c. Ai, meu Deus. Okay. And then sometimes you can simplify, excuse me, sometimes you can simplify these expressions inside the parentheses. Mhm. Okay. Grouping method. So it splits expressions, the expression into groups and factor each group first. And then you can combine, well, you can go ahead and further factorize the expression. So we have, you see, you can just factor, you can group the ones with common elements. So in this case, we grouped a times x and a times y. How can I erase on this? I don't know how to erase. If I have to erase, how do I do it? Maybe use white. Oh, I guess I have to highlight it and erase it and delete it. Okay. Um, so yeah, we're gonna group these two and these two, and then we factor the common term. For these two is gonna be A. For these two, the common term is B. We factorize that A, that B, and then we can further factorize this because we can see that X plus Y is common in these two. So we factorize it, we pull it out, okay? And then we get A plus B times X plus Y. X plus B, my bad. X plus B times X plus Y. So I hope you remember these methods. If you're not sure, you can send me a message. Now the difference of two cubes, you can memorize these or you can use long division to factorize it. So after you find, you can find a zero, you can find one of the zeros using the remainder theorem. You know, if P of K equals to 0, then X minus K is a factor. Remember this? This is so slow. I don't want. What? So annoying. All right, or you can memorize these two. And then just if you have the difference or sum of two cubes, you can go ahead and use this, or you can find a zero and then further simplify using long division. All right, the monic and non-monic. So monic quadratic trinomials, the leading coefficient is 1. That's what monic means. And non-monic, the leading coefficient is not 1. Okay, in this case, the leading coefficient is not 1. So it's not a, it's a non-monic trinomial. Remember we have, let me see, let me share this. Remember we have monomial. What the heck is going on? Monomial. What? All right, let me stop. Wait, why is it so slow? Monomial is one. Are you serious? One term. Binomial. Two terms. What the fuck is going on, man? Serious? What's that fucking sound in here? Trinomials. Three terms. Polynomials. More than three, right? All right. So let's go back to my file. Where did it go? Oh, here. All right. So how do you go about simplifying and factorizing these expressions? First, always look for a common factor first. If you're dealing with a binomial, look for the difference of two squares or sum or difference of two cubes. If you got three terms, look for a quadratic trinomial, quadratic function, quadratic expression. If you got four or more, look for a grouping. Try to use the grouping method. And just remember that these can require the use of two or more of the above strategies at a time. So don't get frustrated and be careful to make sure that you fully, how can I write with this? This is insane. Wow. I can't write with this. Fully factorize. Writing on this PDF file is very annoying. All right, fully factorize the expression. Okay. All right, let's jump into some examples. So you guys can see these in action. So we have this 28 squared plus 22a minus 12. So we have to factorize that. Let's write it on the other side, which is easier for me to write. The whiteboard. New page. We got 20a squared plus 22a minus 12. So we can factorize a, but there's different ways to go about doing this. Um, so the way I do this is I multiply the leading term, the leading coefficient times the constant. So if I do that, I get negative 240, and I need to find two factors of negative 240 that when I add them up, it'll give me positive 22, but when I multiply them together, I'll get negative 240. So those two are going to be positive, so that's going to be plus 30a minus 8a. Okay, so 30 times negative 8 is negative 240. And if I add 30 minus 8, I get 22a. Okay, and now I can group and factorize further. Okay, so this I can factorize the a, and obviously the greatest common factor would be, I can do 10, right? So that'll be 2a plus 3, right? 10a times 2a equals 28 squared. 10a 10a times 3 equals 38. From this, the greatest common factor. And for these two, we're going to have negative 4. Negative 4 times 2a equals negative 8a. And then to get a negative 12, we need to multiply by positive 3. Negative 4 times 3 is negative 12. Now we see that these two expressions have 2a in common, so we can factorize that. 2a plus 3, I meant to say. And then 10a minus 4. All right. Now, we're not finished. This we can still factorize. All right. So we get 2a plus 3. And then this factorize, we can factorize number 2. So I got 5a minus 2 times 2. All right, and that will be the final answer, the fully factorized expression. All right, let's do another one. Now, b, we're gonna have x squared plus 2x plus 1 minus y squared. So what we can do is we see that this is a trinomial, so we can factorize this, and that's going to factorize to x plus 1 times x plus 1 minus y squared, right? Two numbers that will give you 1 when you multiply them, but 2 when you add them up. And then this is the square of x plus 1, right? And what do we have now? We have the difference of two squares, right? X plus 1 squared minus y squared. So we can do x plus 1 plus y times x plus 1 minus y. And that's it. That'll be the fully factorized form of this expression. C, maybe we can do it right here. Too many things on the screen. C. Mx squared minus my squared minus nx squared plus ny squared. So these two have m as in mom, and these in common, and these two have n, so I can factorize that, right? The n, this would be this. All right. And now we can factorize this, the x squared minus y squared. And then we can factorize this difference of two squares, x plus y times x minus y times m minus n. And that's it. That's a fully factorized form for this. Let's take a look at D. We have all right, this is part 2 of factorization lecture. So we're going to continue factorizing some expressions. Next, going to be D. And for D, we have 5x squared minus 34 xy minus 7y squared. All right. So the method that I use, again, I multiply the leading coefficient and the last number and the constant or the last number, and I get negative 35. Then I try to find two factors of negative 35 that when added together will give me negative 34. And those two are negative 35 and 1. So I just rewrite this using those two factors. So that would be negative 35xy plus 1xy minus 7y squared. And now I can group these two and I can group these two. So from here I can factor out 5x. So I get x minus 7y, okay? And then from here I can factor the y. So that'll be x, and then I need a negative 7y squared, so I'm gonna need negative 7y. Now we have a common factor, yeah, this expression x minus 7y. So we can pull that out. And then we get 5x plus y. All right, this is a 7. And that's it. Okay. All right, let's do f. We got x to the 6 minus 1. So this is the difference of two squares. X cubed minus 1. You want to do it this way, just as 1, right? 1 to the third is just 1. And then if you, since this is the difference of two squares, we can factorize this as x cubed plus 1 times x cubed minus 1. And then we know that this is the sum of two cubes, and this is the difference of two cubes. So we can go ahead and simplify that. So we know that the sum of two cubes will be the same as the summation of the two cubes, the two terms that are being cubed, times x squared minus x plus 1. Remember from our previous page, the first term squared, the second term squared, and then the product of the two terms. But if you have the sum, you have to be careful with the signs. Now, the alternative would be to find zeros, right? So you can find zeros. Let's do it that way, x cubed plus 3. So if I find a 0, if I let this be my p of x, I can find a 0, so that's going to give me a factor. And then with that, I can do long division and simplify that. So what number can I plug in here that is going to give me, remember, we take factors of the constant. So factors of 1 are going to be plus or minus 1, right? So we got to try 1, positive 1 or negative 1. So I know that I can see that if I plug in negative 1, I'm going to get negative 1 cubed plus 1. So this is the same as negative 1, right? Plus 1 equals to 0. Therefore, x plus 1 is a factor of this right here. All right? So if I divide x cubed plus 1 by x plus 1, okay? And again, our goal is to factorize this. Now, if you memorize the factorization of the sum of two cubes and the difference of two cubes, you know that the factorization is going to lead us to this, right? But the alternative approach would be to do long division. And then we can do it this way. And then this is x cubed, right? And then this would be x squared times negative. This is 0. This is negative x squared. And then this would be negative x times x, negative x squared. Negative x multiplied by negative. This is too long division. It's not going to be enough. I won't have enough space. And then this would be 0, and this would be x plus 1. And then you know that if I multiply by 1, right, I'm going to get x plus 1, and then when I apply, can I roll it down? Mm, I'm missing one step here, but let me do it here, okay? I'm gonna do it right here in this area. So I know if I multiply 1 times x plus 1, let's say I'm gonna bring this up here. I don't want to confuse you. I'm bringing this x plus 1. These are my last two terms, right? These are the same, right? So if I multiply 1 times x is gonna be x. 1 times 1 is gonna be 1. Well, let me not do that positive. Positive 1, right? Then I multiply by negative, and then this will be 0 and this will be 0. This is my remainder, 0, okay? Remainder 0. And we know that if there is a remainder 0, that means that this is a factor, okay? So you can see x squared minus x plus 1, and that's the same we have here, x squared minus x plus 1, okay? So this would be the alternative approach. You can use long division, and then first you have to find one of the zeros, and then you can divide by that, and then you know that you should get a remainder 0, and you're gonna get the expression simplified. So we have binomial times a trinomial, okay? I just wanted to show you that. And then this, the difference of two cubes is gonna simplify to x minus 1 times x squared plus x plus 1. And that's it. And that's the final answer, okay? If you try to simplify these, you won't get real solutions, okay? The discriminant is going to be negative, so, and the discriminant, remember, is this. And for this case, it's going to be less than 0, so non-real solutions, okay? All right. Let's see. G, we got v squared minus a squared minus 8a minus 16. All right, so what I'm gonna do is I'm gonna group these three. I'm gonna factor the -1. All right, so I'm gonna get a squared plus 8a plus 16. And now two numbers that'll give me 16 when you multiply them, but will give you 8 when you add them up. 4 and 4, right? Okay, so I can simplify that as uh, a plus 4 times a plus 4. Okay. And this is going to be the difference of two squares, right? Minus 1 times a plus 4 squared. So this becomes b squared minus uh, a plus 4 squared. Again, the difference of two squares. So it'll be b, let's start with a plus a plus 4, right? Times b minus, and then this would be b minus a minus 4, and that's it. Because before, let me write it just to make sure you don't get confused. B plus this, right? A plus 4 times b minus a plus 4. And then from this, it simplifies to that. All right. That negative goes into the parenthesis and makes the A and the 4 negative. All right, next one. H. We have, should write smaller. A squared minus 5A minus 10B plus 4AB plus 4B squared. So this one looks a little more complicated, but what we need to do is we need to group, okay? We're gonna group, but first I'm gonna take this right here, 4AB, and I'm gonna rewrite it as 2AB plus 2AB, okay? So I'm gonna do a squared minus 5A minus 10B plus 2AB plus 2AB. So these two are the same, okay? 4AB and 2AB plus 2AB plus 4B squared. And now I'm gonna go ahead and group some of these. I'm gonna group this term, and this term. And I'm gonna group this, that's not, this term, these other three terms, okay? So let me just rewrite it. A squared minus 5A plus 2AB. And then we would have minus 10B plus 2AB plus 4B squared. Okay? And now I'm going to factorize this and this, okay? So from here I can factor out the A, and that's going to be plus 2B. And from here I can factor out 2B. So this is 5. This would be negative. I need to get 2AB, and I got 2B, so that'll be a negative, well, positive 2AB. So 2B times negative 2B times negative A will give me positive 2AB. And then I need to get here a positive 4B squared, so it'll be negative 2B. Edit this part, okay? Edit, remove the part before this. I'm gonna factorize 2B, okay? Excuse me. 2B. So I need to get negative 10B, so that'll be negative 5. I need to get 2AB, and I got 2B, so I need to add A, right? 2B times A, that'll be 2AB. I need to get positive 4B squared, and I got 2B, so I need 2B. All right, now notice that these two are the same, right? Positive A, 2B, 2B, and negative 5. All right, so I can factorize that, and I'll get A, let's do it this way, A plus 2B minus 5. I'm not changing it, it's just rearranging, you know. This is, I got my positive A, I got my positive 2B, and my negative 5. The same here, negative 5A and positive 2B. I'm just writing it this way so I can organize it. You know, A first, B second, and last any constants. And then I got my A and my 2B. So those come in a parenthesis right next to it. A plus 2B. All right. Lastly, we got well, not lastly, next example two, we're gonna get into simplifying uh, algebraic fractions, okay? Fractions. So let's see. Oh no, that's the wrong one. I don't have the file open. Okay, so when simplifying algebraic fractions, okay, you want to factorize the numerator and the denominator, okay? And then cancel any common factors. All right, so those are the two steps you want to try to achieve when dealing with these algebraic fractions, okay? And lastly, when adding or subtracting algebraic fractions, express the fractions with a common denominator. All right, so you, again, when you're dealing with algebraic fractions, you want to follow these steps, follow these directions, all right? So let's do some examples. We have a squared minus 4 divided by a squared minus 2a. So if you go back, factorize the numerator and the denominator. So let's see if we can do that. This is the difference of two squares, so we can do a plus 2 times a minus 2, right? Okay, and the denominator, you can factor out the a, and you get a minus 2, right? And now we can cancel out, right? Dividing out common expressions, right? So a minus 2, a minus 2. That's it. You cannot cancel anything else. So a plus 2 divided by a. That's it, right? Pretty simple. B, we have 2m squared plus 7m minus 15 divided by 6m minus 9. All right. So this numerator, you can factor as we're using my method, right? You multiply this and this, you get negative 30. Two numbers that'll give you negative 30 when you multiply them. And positive 7, that'll be 10 and 3, right? So you can rewrite this as 2m squared plus 10m minus 3m minus 15. All of this divided by this. We can factor out the 3, right? 3 out of this. And then we get 2m minus 3. Now the numerator will become, you can factor out the 2m from here, and you'll get 2m times 8m plus 5 minus 3 times m plus 5. All of this divided by 3 times 2m minus 3. And from this, we can factorize the m plus 5. So we get m plus 5 times 2m minus 3 divided by 3 times 2m minus 3. And then since these are multiplying, we can cancel, common term, well, the same expressions. If you have two expressions which are the same in the numerator and denominator, they become one, right? With numbers or expressions, you can have x plus 1 divided by x plus 1, and this is just 1, okay? All right. So these two will cancel out, become 1, so we get m plus 5 over 3, right? The final answer would be m plus 5 divided by 3. And that's it. Next, we have C. 1 minus t cubed divided by t minus 1. Again, we have the difference of two cubes in the numerator. So we can go ahead and factorize that. As 1 minus t times 1 plus t plus t squared divided by t minus 1. Okay. Then to make these two the same, right? We can factor out the negative. So we can do this t minus 1 negative t plus 1, and then this, can we simplify this? No, right? Let me just rewrite it as t squared plus t plus 1 divided by t minus 1. And then we can cancel these two out, and we're left with negative t squared plus t plus 1. And remember, this number, you're not going to find two factors of 1. That will give you a positive 1 when you multiply them, but 1 when you add them up. So the solutions will be not real. So that will be the final answer. C, D. All right, for D, we have a plus b squared minus c squared. So you can see the difference of two squares, right? Then we have 3a plus 3b minus 3c. So this will become a plus b plus c, right? Times a plus b minus c divided by, we can factor out the 3. So we get this. And now, what can we cancel? Well, a plus b plus c. Now, a plus b minus c, these two can cancel each other out. And the final answer would be a plus b plus c divided by 3. Right? Easy stuff, right? All right, E, with E is gonna get a little more complicated. A little bit, not much. Let's see. We have x minus 2 divided by x plus 2 times 3 times x plus 6 divided by x squared plus 2x minus 8. So this is already factorized. I cannot do anything else to these two, right? But these I can factorize. So let's see, x minus 2 divided by x plus 2. I can factor out a 3, right? And then from this becomes 4 and 2, right? And negative, positive 4, x plus 4 times x minus 2. 4 times negative 2 is negative 8. 4 minus 2 is 2. And then from that, we can cancel these two. Not, yeah, these two, my bad. These two, I'm sorry. And then these two. And then we're left with 3 over x plus 4. That would be the final answer, right? Because I'm looking at my notes and I'm trying to write the solutions, so I might get a little confused sometimes. Next, F. This one is a little lengthier. Let's see, we have a squared minus 2ab plus b squared divided by a squared minus b squared. This is being divided by a minus b over a squared plus a times b. So division, remember, if you're dividing two fractions, so this becomes what? You multiply by the reciprocal, right? So 1 squared times the reciprocal of 2 is 1 over 2. And then we get 1/4, right? So similar situation here. We have to turn this into multiplication and use the reciprocal of this, which is going to be this in the numerator and this a minus b in the denominator. So let's go ahead and do that. But maybe we can start by factorizing, okay? Factorizing. So there's two approaches you can use for this. This is the same as, actually, this expression is the same as a minus b squared, you know? If you multiply this out, a minus b times a minus b, let's see what we get. A times a is 8 squared. This is minus ab minus ab, a times b, plus b squared, right? And then this becomes a squared minus 2ab plus b squared, right? So there you go. This, we got the same answer. So we can rewrite this as this, a minus b squared, right? So let's go ahead and do that. A minus b squared. This is the difference of two squares. So we can do a plus b times a minus b. Let's go ahead and turn this into multiplication. And if we do that, we have to send this to the numerator. And we can factorize it, right? We can factorize it as a times a plus b, right? A times a is a squared, a times b is ab. And then this a minus b stays there. All right. Please do not forget this step. You have to reverse it. You have to use the reciprocal, okay? When you go from division to multiplication. And now it's just a matter of simplifying, canceling out, right? So we get these two will cancel each other out. And then we have a minus b squared, and we have this also, right? A minus b squared right here. These two are the same. So I can just go ahead and cancel these. And all I'm left is just a, right? A. And that's the final answer. Okay? All right. Now for example 3, simplify. We're going to simplify these. Let's see. But now we're going to deal with, well, no, similar, just fraction, algebraic fractions. 3x minus 4 divided by 4 minus x minus 3 divided by 5. So we have to combine these two fractions, so we have to write them with the same denominator, right? So what's the least common factor? Least common multiple, my bad. Least common multiple, I meant to say. So the least common multiple between 4 and 5 would be 20, right? So we can go ahead and there's different ways to do this, right? You can multiply, you just want to make this a 20, so I can go ahead and multiply 3x minus 4 over 4 times 5 over 5. So that's going to make it a 20 minus x minus 3 divided by 5. And to make this a 20, I would have to multiply by 4 over 4, or by 4. But then, again, if you use the other method, we're just doing the same in a different way. We're just multiplying by 1, right? This is 1, this is 1. And then we multiply this, so we get 20, and then we get 15x minus 20 divided by 20, 4x minus 12. All right, now we have the same denominator, so we can go ahead and combine them. And then we get 15x minus 4x, right? This negative distributes into the parentheses, so that'll be 11x. And then we get negative 20 and positive 12, right? Negative 20, negative is positive. Negative 20 and positive 12, that'll be negative 8, right? And that's it. That's, you cannot simplify any further. Okay. Where are we? Next one, B. We have 3y plus 1 divided by 4x plus 3 minus 5y divided by 6x. Again, we got to find the least common multiple. And the least common multiple between these two will be 12x, right? Let's see. Well, no, this. Four, 6, this is 2, 2, this is 3, 2, this is 2 squared times 3. So that'll be 12, yeah. This is a way to find the least common multiple. So you just simplify in prime factors. And then you just write each number as in their prime factorization, and then you just choose, not 3, you choose the highest power, okay, for each number. So we got 2, the highest power is 2, and then 3, we got 3, the only one, so that's the one we choose, and we multiply them together, and that'll give you the least common multiple. All right, so 12x for that. So we can go ahead and write this as 12x. And now I'm going to use the alternative approach. So I take this divided by this and multiply it by this. So 12x divided by 4x is going to be 3 times this. So I get 9y plus 3 plus 12x divided by 6x equals to 2. And then 2 times 3 is 6. And 2 times negative 5y will be negative 10y, right? I'm going to erase this because I need the space. All right. And now I can go ahead and combine like terms. So I got negative y, negative 1, right? Negative y. And this is 9. Is that it? Yes, it is. 9 minus y divided by 12x. Okay. Cool. Let's I don't know. Hello guys, welcome to part 2 of algebraic fractions. So let's get into it. Next, we're going to do C 5 over t minus 7 divided by t squared plus 3t. So again, when you have these algebraic fractions, you want to write them with the same denominator. So let's see, how can we make these two, how can we write them with the same denominator? Let's see. I factorize this so we can see better what's going on. T times t plus 3. So what we need to do to this one to make it, what can we do to make them the same? To make these two algebraic fractions have the same denominator. Well, I can multiply this by t plus 3, right? So if I do it to the denominator, I have to do it to the numerator. So I'm just going to multiply this by t plus 3. And then this. And now they have the same denominator, you see? And I can go ahead and combine them. So I can multiply this. And that will be 5t plus 5 times 3 is 15. And they're going to have the same denominator, t times t plus 3. And then this will be minus 7. So it simplifies to 5t. 15 minus 7 is 8 over t times t plus 3. And that's it, right? So again, you want to make the two denominators the same. So as if, remember, it's the same approach, the same method as if you were dealing with fractions, right? 1/2 and plus, I don't know, 1/3, right? So in this case, to make them the same, you have to multiply this by 3 and this by 2, right? So just a quick review of this. 3 over 3, right? And then the other one has to be multiplied by 2. 1/3 times 2 over 2, right? And you guys can see how this will be the same as this. And then since they have the same denominator, 6, I can just add up the numerators. And this will be 3. So 3 times 6, 6. This will be 3 plus 2 times 1 is 2. So that'll be 5, 6, right? All right. So same applies to algebraic fractions. We have to get the same denominator. So just have to look at them and try to see what you need to multiply by one of them or both of them to be able to get the same denominator. So sometimes you have to multiply both by something, or sometimes just one of them. But the goal is to have the same denominator, okay? Let's see. The 3 over x squared minus 4 plus 2 over x squared minus 2x. So what I'm going to do is I'm going to go ahead and factorize that. Not x squared, x. And then this one would be x times, not 2x. Sorry. X, I'm factorizing the x times x minus 2. So again, I need to make them have the same denominator, right? So let's see, this one's got x plus 2, x minus 2. This one has x minus 2 and x. So I would have to, they're going to have the three elements, right? They're going to have x plus 2, x minus 2, and x. So my denominator is going to need to have that. X plus 2, x minus 2, and x, right? Because I see that this one has x plus 2, this one has x minus 2, this one also has x minus 2, so that's good. But this one has an x, this one doesn't have an x. So I can multiply to, this one is missing an x, right? You know, you can also look, what is this one missing from this one? An x, right? This one has x minus 2, this one has x minus 2, but this one has x and this one doesn't have an x. So I can multiply by x, right? And then this one, again, I will have to make it look like this, x plus 2 times x minus 2 times x. So it's going to be missing x plus 2, right? So now they have the same denominator, x plus 2, x plus 2, x minus 2, x minus 2, and x. So I can go ahead and combine these. It's going to be 3x plus 2x plus 4, right? And then our denominator is x plus 2, x minus 2 times x. And that's going to simplify to 5x plus 4 divided by this. X plus 2 times x minus 2 times x. Okay? All right, next one. E, this one is a little longer. We got 3 over x squared minus 4 plus 2 divided by a squared minus a minus 2 minus 5 divided by x squared plus 3a plus 2. So I want to go ahead and factorize the denominators. So I'm going to get 3 over a plus 2 times a minus 2 plus 2 over a minus 2 times a minus 2 times a plus 1 minus 5 over a plus tomorrow. Sorry, I got a message. 5 over a plus 2 times a plus 1. Let me erase that and do it real quick. Okay, so 3 over a plus 2 times a minus 2 plus 2 over a minus 2 times a plus 1 minus 5 over a plus 2 times a plus 1. So again, our goal is to write them with the same denominator, right? So what elements do we have? What expressions? We got a plus 2, a minus 2. This one, a plus 2 is already here. A plus 1, not here. A plus 2 is here. A plus 1 is here, right? So this is it. The denominator needs to have these elements, okay? It needs to have a plus 2, a minus 2, and a plus 1. So, because these are all the elements present in all of them, in all of the algebraic fractions. All right, so we know that our denominator is going to have a plus 2 times a minus 2 times a plus 1, okay? So, again, different ways to do this. So let's do it. I like doing it this way. What is this one missing? A plus 2 times a minus 2 is missing a plus 1, so I'm going to multiply by that. A plus 2, a minus 2 times a plus 1 over a plus 1. And then we have 2. This one has a minus 2 times a plus 1. A minus 2 times a plus 1. So this one is missing a plus 2. So I'm going to multiply by that. A plus 2 divided by a plus 2. And lastly, this one is missing right here. A plus 2, a plus 1. A plus 2, a plus 1. So it's missing a minus 2, right? A plus 2, a plus 1. So we multiply a plus 2, a plus 1, a minus 2 over a minus 2. Okay, so now you can see that they all have the same denominator, right? This a plus 2, a minus 2, a plus 1, a minus 2 here, a plus 1 is here, a plus 2, a plus 2 is here, a plus 1, and a minus 2. They all have the same denominator. So I'm going to have to use the next page for this. So I'm just going to have to multiply the numerator, or maybe I can do that right down here. So let me erase this. I can go ahead and do it here. Maybe I should write smaller. So my denominator is going to be, let me see, a plus 2 times a minus 2 times a plus 1. And then we have 3 times a plus 1. That'll be 3a plus 3 plus 2 times a plus 2 times 2 is 4. And then negative 5 times a is negative 5a. And negative 5 times negative 2 is positive 10. And then this would simplify to a plus 2 times a minus 2 times a plus 1. And then we have 3, 5a. 3a plus 2a is 5a. 5a minus 5a is 0. And then we have 4 and 3 is 7. Right? 4 and 3 is 7 plus 10 is 17. And that's it. That will be the final answer. Okay? All right. We have one more. Yes, we do have one more. These are long. Usually they take a while to work out. F, we got 1 over a squared minus 1 over b squared divided by 1 over a plus 1 over b. So first you want to combine these two, okay? And then you go ahead and turn this into multiplication. So let's see, if we combine that, we're going to get a squared times e squared, right? So what is this one missing from this one? And what is this one missing from the other one? or just, the least common multiple. To write them in the same denominator, you're going to have both, right? A squared and b squared. You know what? Let me just do it step by step so I don't confuse you. I think that was confusing. So in this case, you're going to multiply this by this denominator. So it's going to be b squared over b squared times 1 over a squared. And then this times this denominator. So we get 1 over b squared times a squared over a squared. Okay. And then we get b squared minus a squared divided by a squared b squared. All right. And then this same approach, right? We can multiply b over b times 1a plus 1 over b times a over a. Let me use these parentheses. And then this will become ab, right? And then we get b plus a, right? All right. So now these two are being divided, right? This is the numerator, this is the denominator. They're being divided. So what I can do is I can turn this into multiplication, right? Multiply by the reciprocal. Let me write it here so it doesn't look confusing. B squared minus a squared divided by a squared times b squared divided, right, by this b plus a over a times b. So if I turn it into multiplication, b squared minus a squared divided by a squared times b squared times ab over b plus a is the same thing as a plus b. Right? Remember, you with these fractions, if you multiply, dividing, you turn into multiplication and you switch it, right, with the reciprocal. And now we can go ahead and factorize this, right? This is the difference of two squares. So we get b plus a times b minus a divided by a squared times b squared times a times b over b plus a, right? Just double checking. B plus a. All right. And now we can see that this will cancel with this one. And then these will cancel with this one. And we're left with a to the first power, b to the first power. And all we're left with is b minus a, right? Right here. B minus a in the numerator divided by a to the first power times b to the first power, right? And that's it. Okay, so that is it for algebraic fractions. If you're one of my students, please do these exercises. Learning guide, 0-5 and 0-6, 0 through 6, 0 through 5, 0 through 6. Okay, if you're not one of my students and have any questions about these, send me a message or drop a comment in the comment section. If you are one of my students, you can send me a question via WeChat. All right, thank you very much for watching, and I'll talk to you guys later. Bye-bye.